Let's talk about what a ratio is. A ratio, and let me just write it here. A ratio is comparing one number to another number, and we're usually doing it in a division. We do this in division because we need a way to run a calculation on it. In some cases, you might see a ratio written like this, a colon b. Now that's great. That does describe that there is a relationship between a and b, that there is a ratio relationship between a and b. But it's not very easy for us to understand how we can use that as a means of calculation. And so we use division. We divide A by B in order to express this ratio. And we can look at how this ratio can be, or how ratios can be used through this idea of what a rate is. For example, a rate is something like distance over time, or a rate could be a price versus, how many of these did you buy? And so then we're looking at a price of a object to if I were to buy just one of them. And let me just give you an example of what that looks like, because that's kind of hard to probably visualize. So for example, let's say you went to a store and you bought $25 worth of shirts, and you bought two of these shirts. You went to another store and you bought $45 worth of shirts, but you bought four of these shirts. And then you went to another store where you bought $30 worth of shirts, and in this case, you bought three. Now, the value, the ratio that we are looking at is a dollar amount over a number. So the number of shirts. I'll just write that down here as number of shirts. So, I think I misspelled that wrong. SHIRTS. There we go. So in this case, this ratio is the number of dollars that we spent on shirts and the number of shirts that I bought. And so the question is, which one of these three ratios gives me the best deal? What was the store that gave you the best deal on shirts? And let's just assume that all of these shirts are exactly the same. So I went to store A and I bought the same, I bought two t-shirts. I went to store B and I bought the same t-shirt four times. And I went to store C and I bought the same t-shirt three times. Which one has the best deal on this particular shirt? Well, it's very hard for us to see any relationship because we are looking at a ratio that is different, especially in the denominator. I'm comparing A with two shirts, B with four, and C with three. The only way that we can really get a decent idea of the relationship between all three of these is by having a denominator that's the same. And then I can really go, okay, well, store A sells one shirt for this dollar amount. Store B sells one shirt for this dollar amount. And store C sells this one shirt for $1 amount. So I'm going to need a calculator. And what I'm going to do is I'm going to take 25 and I'm going to divide that into 2. And that's going to give me 12.5. So I'm going to put this over on the other screen here. So I'm going to write, in this case, 12.5 divided by 1. And here I'm going to, let me just kind of do this on my head here. So 4 into 45 is going to be 1. And that's also going to be 1. And then that's going to give me a 10. So that's going to be 1.11.2. I'll go from there, but I'm thinking that that might be 25. Yeah, so 11.25. And that's 1 over 1. And 3 into 30, well, that's just 10 over 1. Again, what did I do? Well, I divided 2 into 20, or I divided 25 by 2. I divided 45 by 4 and 30 by 3. I did that because I want the denominators to be all exactly the same. Remember, these are ratios. I'm not really looking at exactly 12.5 divided by 1. I'm looking at a relationship between two numbers, the cost and the number of shirts. This is math. This is how we kind of do things. We need to take a real world example and then we put it into a mathematical expression, equation of some kind. We come up with an answer, but we need to express that answer in terms of the real world question that I have asked. And the question that I am asking in this question here, the answer I'm looking for is which store has the better deal? And the only way for me to know that is to express each of these ratios in a way where the denominator, the b, remember a ratio was a divided by b, where the b is the same. If the b is the same, then I can now look at each one of these three stores and go, okay, this is the answer interpreted for the real world solution. One shirt at store B costs $12.5. One shirt at store B costs $11.25. And a shirt at store C costs $10. And so which store is the cheapest? Store C. That's how you can use unit rates to compare values that have a similar. Sometimes you have to change these values so that they are similar. And we're doing this in a way where I'm just dividing 2 into 25 so that I can have a denominator of 1. If I wanted to, I suppose that I could multiply everything here so that the denominator is the same. The greatest common factor of 2, 4, and 3 would end up being 12. So I'd have to multiply this by 6, I'd have to multiply that by 3, and multiply that by 4. I think it's just easier to divide everything by its denominator value, get the denominator equal to 1, and I can compare rates at this point. Now, there is a possibility that I might want to convert rates. So, for example, I have the value 330 minutes. And let's say that I want to convert this to hours. Now, how would I go ahead and do that? Well, I think a lot of you already know how to do this. You're going to look at 330, you're going to divide it by 60. Do you know why that you're doing that, though? So then in line here becomes the conversion, and what we're talking about here is the conversion factor. You probably are taking it for granted, but you are applying a conversion factor to this. You might not understand how you're doing it. You know that that's just how you've been taught to do it. But now we're going to learn why this works, why this conversion factor is actually working. Now, a conversion factor is taking a value that has a relationship to another value. For example, a value of minutes per hour. If I was to, I know that's ugly looking, let me just do that. If I needed to compare a number of minutes to hours, what values could I select? Well, I could say 60 minutes per 1 hour. I could even say 120 minutes for 2 hours. But that's just 60 over 1. And in many ways, what you want to do is you want to have a ratio where 1 is in fact my value. Now that might not always be the case, but if you have a ratio where 1 is in fact in this ratio, this actually does make the conversion a lot easier. So I'm going to use this as my conversion factor. 60 minutes to 1 hour. That's my ratio. Now, this might be really hard to understand, but in math, this is 60 over 1, right? In reality, 60 minutes to 1 hour, that is the same value. It's the same value that we apply in real life, which means that this value practically is 1, because 60 minutes is equal to 1 hour. This value practically is 1. But for our math purposes, to do the conversion factor, it is 60 over 1, because that is the conversion factor that's going to give me my answer. Now, why do I say that? Why am I making this so confusing? Well, in order for me to use a conversion factor on a number like this, I need to use a property that's called the identity property. Remember that property? If I multiply a value by 1, I get that value back. Well, that's exactly what I need to do with 330. I need to multiply 330 by a value that represents 1 so that I can get this value back. But I want this A to be represented differently. Instead of A being in minutes, I want this new value, this value A, to be represented in hours. I need to convert from minutes to hours. And so I do that by taking the value 330, and I'm going to multiply that into 1 over 60. Now, what have I done here? Let me write down that this is 1 hour and that this is 60 minutes. And let me write down here that this is also minutes. What I have done here is I have multiplied 330 by a value that in reality is 1. 1 hour equals 60 minutes. But in math terms, it is 330 multiplied into 1 over 60. Now the conversion factor, you will notice, if I'm converting from minutes to hours, I need the ratio to be written in a way where hours is in the numerator and minutes is now in the denominator. Now you'll notice I wrote it over here, 60 over 1. In here, I'm writing it 1 over 60 because what am I converting to? What I'm converting to needs to be in the numerator, hours. What I'm converting from needs to be in the denominator, minutes. So in this case, 330 multiplied by 1 will be divided by 60. These minutes cancel out, and I'm now left with 330 divided by 60, and this will give me the answer to how many hours are in 330 minutes. And if you're curious about that, that should be 5.5. Now I would go ahead and practice this by taking 5 feet 3 inches and converting that straight to inches. Pause the video, see if you can solve this using the conversion factors that I've taught you, and see if you get the right answer. So pause the video right now. Okay, now that you have got the answer, I hope that you have the answer. If you don't have the answer, then you're not practicing. The answer to this problem is 63 inches. And if you need me to go over this tomorrow, I will most certainly do that. Just ask me and I'll go over it. But right now I want to keep these videos as short as possible. So the answer to this problem was 63, and hopefully that's exactly what you got when you did the conversion factor. Now it's also possible that I might need to convert from one system to another. For example, let's take the value 1,815 feet, and I want to convert this into meters. How would I do that? Well, I need a ratio that describes the relationship between feet and meters, and there is a ratio that does describe that. 1 meter is equal to 3.28 feet. So that is my ratio. That is my conversion factor. Now, am I going to be writing this conversion factor as 1 over 3.28 or as 3.28 over 1? I won't know that until I know what I'm converting to and what I'm converting from. In this case, I am converting from feet to meters. So what goes in my numerator? Meters, that's what I'm converting to. So in this case, meters is in my numerator. So in this case, the conversion factor 1 over 3.28 is in fact what I want to be multiplying 1,815 to. Again, to really cement this home, to really understand how this works, just write the conversion, just write the descriptors right there. So 1,815 feet, 1 meter, 3.828 feet. So in this case, my 1,815 feet is in the numerator here. This feet is in the numerator. This value of feet is in the denominator. These cancel. And I am left with meters. Nothing cancels out meters. And so now I have 1,815 divided by 3.28. And that is a way for me to convert from one system to another. And this is going to give me 553 meters. So to convert from one system to another, I need to know the ratio. So from miles per hour to kilometers per hour, from inches to centimeters, from miles to kilometers. I need to know the conversion rate, the conversion factor for that. And I will give you that. You do not have to memorize these things. I will give you the conversion factor. These problems in the book, they will give you the conversion factor. All you need to do is know how to use them. And how you use them is you simply in order to take any rate or any ratio and convert it from like feet to meters. I need a ratio that I can multiply my value to. That's just called a conversion factor. That's just converting from one value that is measured in one unit to another value that is measured in a completely different unit. Last thing I'm going to talk to you about is a conversion rate. So let's say, for example, that a student ran a 50-yard dash in 5.8 seconds. So I will write that as they ran 50 yards and they ran that in 5.8 seconds. That is my ratio. At what speed did the student run in miles per hour? So I need to convert to a new rate, miles per hour. Right now I have yards per second. In this case, for what I'm converting to, I need miles per hour. So I need to do a conversion twice. I need to convert yards to miles, and I need to convert seconds to hours. And so how do I do that? Well, we do that divide and conquer. Let's first convert yards to miles. What is my conversion ratio for yards to miles? Well, that is 1 mile per 1,760 yards. That is the conversion rate from miles to yards. Now I have to ask, what am I converting from? Yards. What am I converting to? Miles. Therefore, miles is in my numerator. So I multiply 50 over 5.85 by 1 over 1,760 because miles needs to be in my numerator and yards needs to be in my denominator. So now these cancel. Now I've got it. I've got the miles. I've got that converted. So if I were to multiply this out now, I would have 50 times 1 divided by 5.85 times 1,760. And I would have a unit, a measurable, I would have a rate, let's say, in miles per second. That's great, but I need this to be in miles per hour. So now I need a conversion rate that takes me from seconds to hours. And that is written as the following. 1 hour is equal to 3,600 seconds. And again, I'm converting from seconds to hour. But in this case, in this particular case, you will notice that hours is in the denominator, as seconds is in the denominator. So now I need to kind of flip the script just a little bit because I need my conversion of hours to be in the denominator this time. So I need to rewrite this conversion factor as 3,600 over 1. Because hours is found in the denominator, not in the numerator, in the denominator. So these seconds cancel, and I am left with miles per hour. And the conversion expression, it's not an equation, it's an expression, is going to be 50 times 1 times 3,600 divided by 5.8, I think it's just 5.8, times 1,760 times 1. And if you put all of that together, you will get the final answer, 17.6 miles per hour. And that's how you go from one rate to another rate. So be very cognizant of how this works. Go back to this video whenever you need to figure out how you convert from what a conversion rate is, how you convert between rates, converting between units and systems, converting between units, and what exactly does it mean to be comparing unit rates? What exactly is a ratio? And once you know, and once you get used to ratios, we can start moving into proportions and comparing one ratio to another ratio as an equation.